Welcome to Data Management, MDM4U1. I'm your host, Mr. Begg, at Uxbridge Secondary School. And just a quick word about these video lessons. I'm going to try to go through them as quickly as possible to keep the videos short. So I will speak quickly and do my calculations, reasonably quickly, with the understanding that, of course, you have the option of pausing me at any time and even rewinding if you miss anything. Okay? So let's jump in. Our first unit is basically an introduction to probability. So in order to work with probability, we need to have a working understanding of decimals and fractions and percents, because those are all ways of expressing probability. So we just want to make sure that we can convert between these different forms with relative ease. So remember that for this first example, if we're going from a fraction to a decimal, such as 8 over 12, that's really just a division. So 8 over 12 can be thought of as if it's 8 divided by 12. So we could put that in the calculator if we're not sure what that is. And I get decimal 6 repeating. That last 7 on the end is just my calculator rounding it because it can't go in any more decimal places. So it's decimal 6 repeating infinitely. I can express this repeating idea by putting a dot over the 6, which just indicates that we're going to have an infinite repetition of 6s. But we're supposed to go to the nearest hundredth, which means I want 2 decimal places. So if I was to rewrite it as 0.666, and then I'll put a decimal over this to again show that the 6s are repeating. Remember, when we're rounding, if I want to round to the nearest hundredth, that's 2 decimal places. Actually, let's review this for a second. This is the tenths. This is the hundredths. This is thousandths. And if we just keep adding zeros, the next one would be 10,000ths and so on. But anyway, if we want the nearest hundredths, we want to round to 2 decimal places, which means we actually look at the number to the right of that, and if it's 5 or more, we round up. And it is 5 or more, so we are going to round up. So we round up that number that I've highlighted in yellow in the hundredth place up to the next number, which is 7. So that would be our solution for our first conversion. Going from decimal to a fraction, again, we want to understand our places. Look where the last decimal place is. In this case, it's the second one, so that's hundredths again. And so what we can do is we can write it as a number without a decimal, so 0.35, just to drop the decimal, call it 35, but put it over 100. And now we've got a fraction, but we want it in lowest terms. We always want to put things in lowest terms. So we look for a number that divides evenly into top and bottom. And I can see that they're both divisible by 5 for starters. And I'll get 7 over 20. I should still check to see if I can go farther, but 7 is a prime number, so I'll quickly realize that since 7 doesn't go into 20, there's nothing that's going to go into both of them. This next one has a final decimal place in the thousandths place, so I can write 675 over 1,000 and then divide. And again, I know that 5 goes into both of these numbers. If I do 675, let's see, it's going to go in 100, and then it's going to go in another 37 times. For some reason, I'm drawing a blank. I better, it's all good to do mental math, but if I'm 135 times. 135 times. So as I was starting to say, it's great to do mental math, but we also don't want to neglect our calculators if there's any risk in making a mistake. So I got 135 over 200, because I definitely know that 1,000 divided by 5 is 200. So again, I check, can I go further? Well, yeah, both of these are divisible by 5 again, and I know that 5 goes into 100 20 times and 35 7 times, so I must have 27 on the top here, and it goes into 240 times, and if I check, there's nothing that goes into both 27 and 40 other than the number 1, which doesn't help me any, so that must be my answer. When we have to convert a repeating decimal to a fraction, that's a little bit trickier. So what this means here is that we've got 0.47. That line over the 47 means that we're repeating those two digits forever. It just keeps going. We've heard before, probably in grade 9 or maybe earlier, that we can change something into a fraction, into a rational number, if it's a repeating decimal. But we may not have been told how. So here's a technique we can use. It's sort of a workaround, a way to do it. So I want to change this decimal that I've written here, repeating over and over, into a fraction. So the workaround is figure out how many digits are repeating. So again, obviously there's the 2 digits repeating, and the last digit of the repeating numbers, the 7, is in the hundredths place. It's the second decimal place, right? So what I can do is I can multiply, or actually, yes, let's let this equal x. All right, so x is going to equal this number. I can multiply both sides of this equation by 100, because that's, again, where my last decimal of my repeating number lies. So I multiply by 100, I get 100x, and then of course I've got 47.47, and it's still repeating over and over. And then if I subtract, so I'll line these up vertically, and I will line up my decimal places, and I can subtract on the left side, I can subtract on the right side. If I do 100x minus 1x, because that's assumed to be a 1, I end up with 99x. And if I subtract on the right side, the decimal parts just cancel each other out, right? And then I just have 47 minus 0, which is just 47. And through this technique, I've gotten rid of the decimal part, and now I've got a simple equation that I can isolate x in. I can divide both sides by 99, and it turns out that 47 divided by 99 should be my answer. But we can confirm that. Let's go check that on a calculator. 47 divided by 99 equals 0.474747, etc. And it would keep going, except that, again, my calculator has run out of decimal places, so it just rounded. Okay, we also have to work with fractions in terms of sometimes we're going to have to add fractions together, for sure. When we get into more complicated probabilities, we might have to add the probability of one thing happening plus the probability of another to get the overall probability. So, quick review of that definitely is in order. Remember, in order to add fractions, we must have a common denominator. So right now in this one, we don't have a common denominator, but our lowest common denominator can be found if we multiply the two denominators we have together. So say I could multiply the 4 on the bottom of the first fraction by 5, and then I'd get 20. However, I can't just multiply the bottom by something, because then I'm changing the value. So I have to multiply the top by the same thing. And if I multiply the second fraction by 4, I'll get 20 again as a denominator, but I have to do the top by the same thing. So I end up with 15 over 20 plus 8 over 20. Now that I have a common denominator, remember we just add the tops together, just add the numerators together, so I end up with 23 over 20. And it says to put it in lowest terms, which we should be doing always anyway, always looking for lowest terms. In this case, 23 is a prime number, so I'm not going to be able to break it down any further. so it's already in lowest terms. Same deal goes for subtraction as for adding. We need that common denominator. The lowest common denominator would come from multiplying 8 by 3 and 3 by 8. I'm just using a different color. You'll see I use different colors a lot in my lessons just to try to draw your attention to certain things. So right now I'm just trying to draw your attention that I'm multiplying by 3 over 3 to get that common denominator, but 3 over 3 is just equal to 1, so I'm not actually changing the value of the fraction, I'm just giving it different numbers. For this one I have to multiply by 8 on the bottom, so I'm going to multiply by 8 on the top as well, so I get 21 over 24 minus 8 over 24. And again, I just subtract the numerators. I've got 13 over 24. And again, I should try to reduce, but there's nothing that goes into 13 because it is a prime number. Multiplying and dividing fractions, okay, we don't need a common denominator. I'm going to write that in bold and underline it in red and highlight it, because I always find there's some people who try to get common denominators for multiplying or dividing when it's absolutely not necessary, and therefore just make the question way too hard. So please don't try to get a common denominator for multiplying or dividing. All we need to do is multiply top times top and bottom times bottom and reduce. And 6 goes into both 6 and 72. Goes into 6 one time and into 72 12 times. But here's a better way to do it. So there's nothing wrong with this, except for the fact that sometimes we'll get big numbers doing it this way. So another way to do it, a better way, if I just copy these numbers out again, 3 over 8 times 2 over 9 is to reduce before multiplying. So I can reduce, if it's a multiplication, I can reduce any number on the top, like of either fraction, with any number on the bottom of either fraction. So for example, it jumps out to me that 2 and 8 are both even numbers. So I can divide them both by 2, even though they're not in the same fraction, and I'm still good. I can divide both 3 and 9 by 3. And then I would multiply together the parts that, the numbers that I'm left with. So I'd have 1 times 1 over 4 times 3. 1 times 1 is 1, 4 times 3 is 12. And I get the same answer. And that may not seem like it's any easier to you, and for this particular fraction, this particular question, maybe it isn't, because the numbers are relatively small. But if we get numbers that are bigger, it definitely will make a difference to reduce first, to keep our numbers smaller, to make things easier. Otherwise, we might overlook things that we can reduce. Dividing is the same as multiplying, except that we can change it. We just need to change it to a multiplication. So if we're dividing by 2/3, we can flip that 2/3 and make it 3/2. So I flip that fraction upside down, and now I've got, as a multiplication, I'd reduce if I could, but there's nothing to reduce, so 3 times 1 is 3, and 2 times 2 is 4, and that's it. This one's done. I can't reduce this any further. And that is it for our first lesson. Now there's a homework practice questions. It's called 1.0, and you'll find that in OneNote as well.